First, I'd like to show you that the harmonic series, represented by this series of numbers from the fundamental to the octave to the fifth to the octave, each multiple is a frequency. So this is this movable one. We use it starting on this low C here, but it doesn't matter where you put the harmonic series. All the notes above it are in proportion to whatever note is the fundamental of the series. Now, a little recap on the system we use to figure out minor and major. We numbered the degrees of the scale 1, 2, 3, 4, 5, 6, 7, and 1 again. And we just discovered that if we go 1, 2, 3, and 4, 5, if we play the first, third, and fifth of the scale, we get tone, tone. So that's how far it is from here to here. But it's only a tone and a half from here to here. That is 1, 2, 3, 4 semitones from here to here, and only 3 semitones from here to here. And that was used with this graphic to show different ways to look at it. 1, 2, 3, 4, which we can call 2 tones or 4 semitones. But probably a better way to identify it is a major third is that distance. It is those 2 tones. The reason we call it a third, it's the number it starts with and finishes with. 1, 2, 3. This would be a fourth. This would be a fifth. So there's the third. These are all thirds, but we discovered that this third is the minor third. It's only 3 semitones or a tone and a half, and this one's 4 semitones or 2 tones. It's probably better to think of it as being 2 tones makes a major third, and a tone and a half makes a minor third. Nonetheless, that is the construction of a major chord. And so if we look at those distances and what it would be, this supposed to be my thumb, middle finger, and pinky. If we were to play the first, third, and fifth notes, we'd get a major scale. And if we went up to here, a major chord, if we went up a note, this would be a minor because it should be this one. That'd be major. Another way to look at it is if we went here and we just reversed it. So now we see that playing it with the left hand. So if you invert this thing, turn it upside down, it has this little interval, tone and a half, the minor third on the bottom, and the major third on the top. That's a minor chord, and that's the major chord. Alright, another way that we showed the relation between a C major chord and its relative minor. So, in the scale, we have all the notes of the C major scale making up the same notes of the A minor scale. They're all the same white notes, just a different starting place. So, because it's the same note, they're related. Just like the one major chord, C major chord, if we just take these 2 notes as the major third and put a minor third below, it's still using all white notes, but we get the minor version. We have a minor chord, A minor, which is the relative minor of C major. Then we took this minor chord and thought, well, instead of going all the way up here to C major, why don't we just put this G on top and on the bottom, and we get a C major chord in what's known as second inversion. That's just a fancy word for same notes in a different place. And A minor in root position means the name of the chord's on the bottom. So we have the same 2 chords, A minor and C major, where only the bottom note moved. And we were able to show that these 2 notes in fact do stay exactly the same, and that's what creates the tonal stability or the tonal relationship between C major and A minor. And we used Leonard Cohen's Hallelujah. I heard it was a secret place, and so on. Anyway, and how you would sing that. And then we looked at where they would actually be compared to the piano. And saw that. We call this 0. We call this -14 because to sing it in tune, you have to be 14% of a semitone, or 14 cents, lower than where it would be on a piano. That's when this major third becomes in tune. And this note would be 2 cents sharp. Okay, so that's that chord. But what would this chord be? Well, this is still 14 cents flat. This pushes this one to be 16 cents flat because this has to be 2 cents bigger, pushing this down. So this is -16, this is +2. And that's not the way we often conceive of going from the 5th degree of the scale to the 6th degree. But in this case, it actually is a small step. Okay, and that was our explanations of major and minor and tonal stability and anchors, these being the anchor. They're the ones that stay, and this is the one that goes. This is when it goes to an A, it goes to where it makes perfect intonation with what's already been established and anchored. I hope you like the graphic, but if the explanation is too fast, you should go back to this video, major and minor, and watch it. It moves slowly, especially the first part, and then only introduces these concepts in the end, which is where we're starting now. I'm going to demonstrate the difference between singing a chord in tune with harmonic tuning and what it would be like on the pianos or a keyboard. So this keyboard, I'm going to use the 5th on the piano keyboard, and I'm going to sing the 3rd inside this 5th. And the reason is the 5th, you listen carefully, is very close to being in tune. The harmonic is very close to the equal temperament, and you'll hear it go, wow, listen. So it's phasing pretty slow. If you go up an octave, faster and faster still. Right here, it's in tune pretty good. I'm going to sing the F sharp. And I'm going to try and hold it steady, best I can. And then put this F sharp on top of it. Once I've got it in tune, you'll see what happens. I'm going to do the same thing down here, but in a full voice on the C sharp. So this 5th is pretty close to being in tune. You can hear it pulsing a bit, but anyway, I'm going to sing the C sharp in a full voice. Make that a falsetto. You can hear it happen. Now I'm going to put the 7th in and show you how much worse that is. First I'm going to sing the 7th and bend down a little, bend up, and zone it in. And then I'm going to add the piano 7th. So 1, 3, 5, 7. Try to hold it steady. So you can hear the clear difference between our 7th, the harmonic one that blends, and the equal temperament. You put them both together, you got terrible. You put them on one or the other, That's okay, but it's foul compared to singing or winds or strings playing this chord in tune. It's this foul times 4. We now know that contained with any note you're singing are the overtones of that note. So if we were singing this F, inside that sound of our voice would also be twice that frequency, 3 times, 4 times, 5 times, and so on. The multiples of that frequency are the harmonic series. And that the relationship between all of those is where we get our harmonies from. So let's put it on a C. If we're singing the C, contained would be the C above it, the G above that, and then here you see like the major triad, 4, 5 to 6. That's where we get the major chord from. And the minor chord is a little trickier, but when we keep these two and we make a fifth below, it's that one. You can actually find it in the harmonic series if you go up here to 15. Here it is. So that's contained within it, and what we're going to find out that every chord in Barbershop and a whole lot more are contained within the harmonic series. And we know that if we look at those proportions in a string length, for example, or inside a pipe that you can't see but it behaves the same way, like brass instruments and woodwinds, but in a string you can actually see it. So this is the string vibrating over its whole length. Within that, if you touched it here, you'd excite just that, and you would have filtered this out because it can't move there. That's a nodal point. But we can see on a string that we have the fundamental, the first harmonic, the second harmonic, the third harmonic, the fourth, fifth, sixth, 7 wavelengths per length of string. And we see here they've been labeled. So if you go halfway, so that's proportion, 1 to 2. We've divided it in half. We make an octave. If we divide 1/3 of that again, the distance from a half to a third is a perfect fifth. If we go from 3 wavelengths to 4, we've got a perfect fourth. 4 to 5, we've got a major third. 5 to 6, we've got this minor third that we've discovered. And notice when I said this is not even a minor third, well here they have not labeled it for that reason. It's a way smaller minor third. It's written as a minor third, but we should call it what it is. They did say it's a tritone from here to here, which is important because it is. It's the fundamental tension interval in the dominant chord that Bernstein was talking about. Okay, so we now know all of these, and it might be a nice way to look at it this way if you had a keyboard, that this harmonic series 1, 2, 3, 4, 5 would also be one wavelength, 2, 3, 4, 5, 6, and so on. Okay, now that we know these relationships, the next thing is to really understand, there they all are. There's these notes put on staff paper so that I can label them in how many cents, sharp or flat they are. That is, how many percent of a semitone they are different from the artificial equal temperament. Okay, you'll understand more about temperament after we do this, but let's say that the piano notes equal temperament are equally spaced apart. No matter what the relationship does, it is still an exact same amount. Every semitone is the same, every tone is the same, every major third or minor third, every interval is the same in every octave of the piano. They have divided 12 equal semitones, that's why they call it equal temperament. Now, it doesn't sound as good, but it's a good compromise. So let's measure from it and see in the real series, the real harmonic relationships, how much different they are to equal temperament. So what we find is the first octave is exact, that's why there's no number above it. But if we go to the fifth, it says plus 2 C, meaning cents, plus 2 cents. 2% bigger, 2% of a semitone bigger. Okay, that's what they're saying this real fifth is compared to a piano. So a piano is 2% small. Now we get the octave again, no number. That's because all the octaves are in tune perfectly. All these C's have no indication. You could put 0 in there if you wanted to. Okay, so now we get to the octave again at 0. And we go to the E as minus 14. That means it's 14 cents smaller. So when we sing this major third, we have to keep that third 14% of a semitone smaller than the piano third, in spite of how many times you hear it the other way around. And there's lots of reasons for that, why these mistakes are made, but they imply certain things that are part of the problem of going flat. Okay, so this one's 14 cents flat. There's the fifth again, an octave higher, at 2 cents sharp. Now here's the real culprit, the Barbershop seventh, part of our dominant seventh, if you will. Our Barbershop seventh is 31 cents flat. That's almost a third, virtually a third of a semitone flatter than what you would hear on the piano. So that's what you were hearing most prominently when I demonstrated singing it and then introducing the piano note. So if we start to know this series, we'll know how to tune chords, especially with Melodyne, where you can actually type in, if this is your grid, equal temperament, you can type in how many cents flat or sharp it is. But understanding it will help us sing better. Okay, so you can memorize the rest of this if you want, but we never use this 11th harmonic. God knows I've tried, but there's no way you can make it sound good. Or this one either. But there probably might be a case for that one. I'm open to find out. This is what we need to know, really. The third and the seventh. The ninth is also very important to know, because the ninth is 4 cents sharp, and we're going to find out that what we call this ninth is can actually be a different note, written the same, but you'll find out. So remember 4 cents sharp. And one more, the leading tone, the leading note is 12 cents flat, not sharp, as we've always been told. And I can prove why that will cause us to go flat, ironically. But remember, minus 12 plus 4, minus 31 is the big one, and minus 14 is the other big one. And of course, fifths are 2 cents too big, or if you look at the other way around, a fourth is 2 cents too small. Now, armed with this little bit of knowledge, what happens if we say, okay, now we know how to tune chords, why don't we just tune the piano that way in the first place? Okay, let's do that. So, let's say we tune the C to be whatever we want, and we say, remember the fifth was 2 cents too big, so let's tune it that way. Let's tune it at, I'll leave the plus off there, it's 2 cents too big. And the third, remember, was minus 14, so let's do that. Let's go minus 14. This was minus 12. This is 0. This is 0. This is plus 2. This has to be minus 2 because it's a fourth. Okay? And we know that this was 4. Okay, now let's figure out what this A is going to be. So let's say we tune it this way. And remember when we did our major third and then we made a perfect fifth down, and minus 14 had to be minus 16 because it's bigger. It's 2 cents bigger than. So this makes this a minus 16. So let's just write it up here. Minus 16. Okay, there's at least the white notes. What do we get? Okay, let's look at a C major chord. C, E, G. Check, check, check. This chord will sound perfect, just like if singers were to sing it. Let's write this down. Okay. So we got C, E, G. That's going to be check, check, check. That's what check this high C too. Okay, so there's our C chord. And we know that it's when a chord sounds perfectly, it's going to be minus 14 plus 2. Okay, what happens on F, A, C? What do we have? F, A, C. Well, F to A is actually, remember, that's minus 2 to minus, so it's actually minus 14, because you're already minus 2 to minus 16. That's 14 cents too small. And here's your fifth, which is, this is too low to start with, so it's, the fifth is too big. So FAC is perfect. If you played FAC on this tuning, we would get check, check, check. Beautiful. Okay, we only need one more primary triad, which is a major triad. And what do we get? 2 minus 12, that's, looks like a half, minus 12, and 4. Let's just write this one up here. Okay, so plus 2 to minus 12 is a minus 14. Check. 2 to 4 is plus 2. Check. So what do we get? We get a perfect G, B, and D. I'll put it down here. All that works out. Wow. As long as we only play C's, F's, and G's, we will have perfect sounding chords, which will do pretty much a lot of country and a lot of folk music around the world. But what happens if we do minor chords? Well, okay, let's do E minor right here. Okay, so we know that the minor third, let's look at it. A minor third from minus 14 to plus 2 means that the minor third is actually 16 bigger. We hear this one backwards all the time too. But this one is actually 16 cents bigger. This minor third that we want to hear is 16 cents bigger. And you'll see that in the F chord it is, right? From there to there, it's 16 cents bigger. And from here to here, it's 16 cents bigger. So we know all our minor thirds, part of the major chord, are all perfect, are harmonic, and will sound great. Now what if we made a minor chord though? Okay, let's take from there to there. What do you know? We've already seen it's 16 too big. Good. And we know the fifth is good. So we now know that our E minor chord is going to sound perfect. And actually, our C major 7 is going to sound perfect. What about this minor chord? A, C, E. Oh, let's do it here. A, C, E. Our minor chord. Is this 16 too big? Yes. Is this 14 too small? Yes. Is the fifth 2 cents too big? Yes. And our A minor chord comes in beautifully. Okay. Now, there's another one. D minor. Here's our D minor chord. Is this 16 cents too big? No, 6 cents too small. Goes from plus 4 to minus 2. I mean, it's 6 cents too small, not 16 cents too big. Bad. This will be foul. Okay? See again? Plus 4 to minus 2. It's too small. And our minor third should be too big by 16, and it's too small by 6. That's a total of 22 cents wrong, if you will. This will not sound good. How about the fifth? 4 to minus 16. No. That means it's 20 cents too small. That will really sound foul. Now, the major third part, we already know it's going to sound good because it's part of the F chord. So that interval will sound right, but this will sound wrong, and that will sound wrong. And D minor, a very common chord, will not work with this tuning. There's the culprit right here, but we know that's got to be right because it's part of the G major chord. Extremely important to have it. So now we have a conflict. Well, why don't we just fix that and make two different Ds? Absurd, you say? Wow, wait till you see. Okay, so we need two different Ds. The other one has got to be minus 18. And there it is again. What are the difference between that? 22 cents difference between these two different Ds. They will appear as a D on the page, both of them. But unless you know what the chord is, or who you're tuning to, you are not going to get this right. And we hear this as a culprit of mistaken intonation all the time. Okay, now there's one other big chord. There's lots of things that will happen, and even worse with the black notes. But what about our 5/7 chord, our dominant chord? And what is that? It's built on G, B, D, F, and that's where we get our Barbershop 7th. So let's just do a little more here. We know that that's minus 14, and we know that this is minus 2. Okay, so we're just duplicating that. So let's build our chord, G, B, D, F. And what do we get? Well, we know the G, B, D part is already perfect. It's going to sound beautiful. But let's throw that F on top of there, and what do we get? It should be minus 31, right? Remember, the 7th is minus 31? But we're already plus 2. So in fact, it only has to be minus 29. And if we put a minus 29 in this chord, it would sound perfect. That means we need two of these chords. Two of these notes. And in fact, they are two different notes. They're written the same on the page. But you sure sing it a lot different whether you're the part of the other chords it belongs to, or you're part of this chord it belongs to. Minus 29. Look at that. That's more than a quarter of a tone difference between those. This one's almost a quarter of a tone difference between them. So now we see that even with these simple triads, you need multiple tunings. And this is why you can't have a fixed pitched instrument like a keyboard with only 12 notes. You would actually have to have a keyboard with many different notes to be able to play these chords in tune. So this goes back from 1648. You see, our forefathers have been grappling with this problem for centuries, in fact millennia. Pythagoras figured out these problems, and probably many others. So that's the kind of keyboard you might need. So people have been trying to do this where they can solve every possible combination, or a keyboard like this. And there are guitars built that, have many different frets in different positions to try and solve the problem. But what it comes down to is that you need many different tunings for any given written note. Maybe this will now make sense. There is no perfection, only varying tastes and corruption. And over 150 kinds of temperaments have been used over the course of recorded music history, and none of them are completely pure. But we are. We can sing and adjust each interval. And all we have to do is sing what sounds best. And that is those relationships. And that is those relationships. And those relationships. So this is an Irish blessing. Not the one we do, but the one that Traditional arranged. That's a joke. Foray does this one. And what I've done is written out all the way through how many cents flat or sharp each note would be compared to equal temperament. So, and I write it below the part. So minus 18 is this bass G, which you would think would be, anyway, it's minus 18. Here's the B flat at minus 2, the lead is on an F at 0, and the tenor's at minus 16. So these sets of 4 numbers go through for each chord. And I've color coded them to do like a medium in the flat category is minus, is in orange, minus 18, minus 16, 12, 14. So in the minus 10 to minus 18 range. The severe ones, minus 25 to 45, are in red. Here's a minus 29, 31, 43. And you might say, well, how can you get minus 43 when a seventh is the worst one at minus 31? Well, it depends on where you're starting. And you might think, well, that's going to lead us flat. Well, no. It's not doing it. It's going to lead you flat. Okay, and then I went all the way through and I tallied them up at the end. And the basses, baritone, lead, and tenor. And we did the totals. And the tenor had, the black ones are like fairly normal notes, like fifths that are only a little bit out. And they had like 29, 29, 30, and 50, or 49. So they're virtually all the same, but basses have definitely more of the normal notes. In the moderate category, the tenors had 25, the leads had 21, the baritones had 26, and the basses only had 6, often singing the root or the fifth. And in the severe category, the red, tenors had 12, leads had 12, baritones had 10, basses only 2. And in the green category is the plus. These are ones that are corrected on the positive side. And tenors had 2, baritones had 2, and basses had 2. And here it is right here. Lead didn't have any because they're holding that thing we call a post. They're holding the post, and we sometimes have to keep that major third small. If we're singing now the root, we'll have to, it'll draw it up. So here's the tenor on an F as a post, and the basses and baritones have to suck it up by 14, which makes the baritone 16, which makes the baritones plus 16 plus 14. The F's at 0, and there's another D flat, an octave from the bass, also has to be plus 14, because it's an octave. Alright, so that's interesting, but what does that mean, all these different notes? I wonder how many notes there are required for this whole thing. Funny you should ask. So I tallied them all up, and the number of different F's, we have one at 0, happens many times, one at minus 27, one at plus 14. We need 3 F's. We only need 1 F sharp, but we need 3 G's, 3G, minus 18 plus 4. We already know about those two from this, minus 18 and 4, but we also needed one at minus 45. G sharps, 2 of them, plus 18 and minus 26. A's, we need 2 of them, minus 14, typically, and plus 8. B flats, we needed 3 of them, minus 2, minus 29, minus 10. We needed 1 B natural, we needed 2 C's, we needed 3 C sharps, we needed 3 D's, we needed 2 E flats or D sharps, and we only needed 1 E. How many notes do we need? We needed 25 notes just to sing this, and it's not a complex song. There's lots of simple relationships in this. 25 notes, not 12. And now you understand why people are trying to figure out a way that you can set pitches and actually play things that sound good.